الزهراء إن شاء الله.
So the first author from Ajman University. أنا أسأل الأوتر إذا كان حاضر البرزنتيشن.
دكتور الآن أعطينا الصلاحية للجميع للتحدث، فتكرما الذي يبدأ يستطيع أن يتحدث ويبدأ بالورقة البحثية المتعلقة به. دكتور لديك الكلمة.
أوكي، شكرا حضورنا الكرام. نبدأ على بركة الله. الورقة الأولى Titled Machine Learning Approach for the Design of Assessment Outcomes Recommendation System, presented by Fatim El-Zahra, Lams Dalbeh, Shayma Munir, Abu Zitar, from Ajman University, from United Arab Emirates. So you have the talk. You have 10 minutes to present your work, please.
السلام عليكم. أنا الدكتور محمد الحاج حسن من الأردن. أرجو من الإخوة المنظمين التنبه إلى أن الوقت يضيع، والذين سيقدمون أوراقهم لم يتجاوبوا مع رئيس الجلسة حتى الآن.
مقعد.
دكتور نعم، ننتقل إلى بريزنتر آخر.
أوكي، ننتقل لبريزنتر آخر. ننتقل للنشرية الثانية titled An Embedded Deep Learning Computer Vision An Embedded Deep Learning Computer Vision Method for Driver Distraction Detection, presented by Adnan Shawat from University of Michigan, United States of America. Adnan, you are here? Adnan Shawat. I don't see Adnan Shawat. I asked the webmaster if he can present the talk, the video talk.
الأستاذ الدكتور عدنان شعوت لو سمحت. عدنان شعوت اسمه.
عدنان شعوت من المعذرة. عدنان شعوت. نتعدى للنشرية الثالثة. إذا عدنان شعوت غير حاضر نتعدى للنشرية الثالثة titled State of the Art Smart Doorbell Systems. نفس الشيء النشرية نفس الأوتر عدنان شعوت أظن غير حاضر. نتعدى للنشرية الموالية Artificial Intelligence Abilities to Support Library Service that we present will be by Jamila Hamdan from Sultan Qaboos University from Oman. تفضل دكتور لك الكلمة.
السلام عليكم. بس من وين أعمل الشير سكرين؟ ما واضح.
بإمكانك الآن يا أستاذة جميلة تعمل الشير سكرين.
أيوة الحين.
أوكي يا أستاذة جميلة.
حتى الآن ما أقدر لأن host disabled participate screen sharing. لو تعطوني صلاحية
الآن يا أستاذة.
ما زال نفس المشكلة. أيوة الحين.
الحين أتوقع خلاص لأن أعطيتك هوست.
واضح الحين؟
نعم. الآن أوكي.
Good.
السلام عليكم ورحمة الله وبركاته. Today I will present my paper scientific is about the artificial intelligence abilities to support library services. It's done by me, Jamila Al-Amri, and Dr. Noor Al-Sheikh Uthman. We will talk introduction about the artificial intelligence and then the problem statement of the study. Also, we will talk about the study objectives and questions, then the importance of the study, and then the research methodology. After that, we'll talk the most important literature reviews, and then the results. In conclusion, we will talk the conclusion and some recommendation of the results. First, of all, as we know, now the world has withstood many technology changes that affecting the lives of everyone and every organization that will confide to a specific group, that not confide for the specific group, but also combined for everyone and every organization. And we know that there is no secret of anyone that importance of artificial intelligence as a mainstay in bringing about the qualitative and that affects for the function of organization in general. Also, as we know, this artificial intelligence is the one of the fourth industrial revolution, and it is like the comprehensive development in all aspects of life and work. And this artificial intelligence also affect positively for the libraries and information centers. And some of libraries are using of this new techniques in many services and in many wares. The problem statement of this study, as I said before, there are many technological applications that are witnessing and wide development in various fields, and the libraries and information centers have a share in that. So which will make a major change in this the services provided. So this application of artificial intelligence comes to present a new form in library environment. So from this idea of providing this modern technology and its application, we decided to do like this study to know how the libraries can use and apply these new technologies. The study objectives of this study, we want to identify the reality of employing this artificial intelligence in libraries, in any types of libraries, and how can be like a relationship between this intelligence artificial and the knowledge management. Also, we want to know to exposing the relationship between this technique and how can affect for the even technical services or administrative services, and how can that will affect for the knowledge management. Also, we want to know the challenges that are facing and how can the library can solve this challenge to add this new technology. The importance of the study. We have two sides of importance of the study. The first one is theoretical significance. We know that the application of artificial intelligence is one of the recent topics that have appeared in the technological area at the present time. And due to this rapid technological process in this field and the resort to many institutions to adopt modern technology, so I hope this study adds something new in Arabic literature review. And in the other side, for the practical significance, it's hoped that the result will benefit for the libraries and can use and apply these new technologies for every services and every things in the libraries. The research method, we use the descriptive methods by content analysis, and we take the most related literature reviews and the study from foreign studies or Arabic studies, and we analyze these studies and we try to know where are the libraries that are using this intelligent artificial intelligence. We get many things of the employing of artificial intelligence, and there are many services that are using the artificial intelligence in some services in the libraries. First, we found this is coming in the machine learning by using the expert systems and rewards. Some of the libraries are using this artificial intelligence and we also found there are many libraries that are using this artificial intelligence in library services, references services, by making knowledge based and making sometimes user interfaces. All of these are contained with the databases, and it will be like the great using of the artificial intelligence. And some of the examples we found in the literature review, we found the medical databases. This medical databases is like a container that like expert systems to build a specific specialized knowledge bases for the nursing and doctors in the medical library. It is like it's like a list of the frequently asked questions, and make this and add these techniques to be like the something new for this medical library. Also, we ask how the library can apply this to new technology. Also, many libraries provide this appropriate techniques by identifier. How can use this artificial intelligence in the library? By using the RFID technology. We know the RFID technology is more related for the artificial intelligence and can be more interactive between the library and the users or the employee inside the library. So this is some of the examples of using artificial intelligence in the world in different libraries. This is the title of study. I am a report I found to help you. This study is very great. It shows us what are the reports are using in the libraries. The report or us is the reports in the national libraries in Singapore. It is like a reader for all the shelves that are putting in the libraries, and the second one is the report now is a new technique is using for the public Western library in USA. It is in the children library. It uses for the computer programming skills. In Oman, we have also a report. It is Afaq al-Ma'rifah report. It is the first report for library in Oman. You can find it in Creative Center in Nazwa. The second objective of this study, we want to exposing the relationship between artificial intelligence application and their ability to develop technical and administrative process in libraries of knowledge management. I found also there are some using of the technical and administrative process. First of one, the equation of the services in library by making the list our expert system in the equation services, and the equation services is the most important services in library. By the librarian can buy and can add something new for the libraries. They make like expert system that help him or her to buy the books or the money sources in library. Also, we have another using of the artificial intelligence in the bibliographic cataloging by making indexes to develop the objective research of researcher and make like a list for the LCHI. It is more related for the indexing and classification services. The third, okay. And the third,
you have just 1 minute, please, kindly.
Okay, the challenge that are facing the libraries to apply this artificial intelligence, we get the three most challenges. First of one, lack of qualified materials and human equipment. Also, the employees' lack of familiarity with it, and some of times the library is not more, have small area. They cannot add something new for the library. And the result, there are a lot of libraries that apply artificial intelligence technology. Also, the available studies discuss various aspects, and some of studies is trying to talk about all services, and some of studies is try to tell us about one services only. Also, the application of artificial intelligence requires the availability of the good requirements and strong technical equipment. And our conclusion and recommendations, they are necessary for libraries and information system centers to strive to keep on with this change of artificial intelligence and increasing the fields of study to explore the requirements of artificial intelligence technology and also diversity the services provided by artificial intelligence in the library and activating them effectively. Thank you for your listening, and these are the references that we have used in the study. Thank you.
Thank you very much, Dr. Jamila. It's very beneficial. Your presentation very beneficial and important. We speak about intelligent library. We speak about RFID technology and wireless. We speak about intelligence. So are there some questions?
Okay.
Any question, please? So I have a question about the data. Is this project is valorized? Yeah, is valorized and used in your library?
In my library in Oman?
Yes.
It is also, it is only my study is analyzing the studies that are related for the artificial intelligence. But I have this type of the Afaq al-Ma'rifa report. It is applied in the library in Oman. It is like something new that I did now in Oman.
And about the data used, how much, how many books, how many magazines, how many documents can be considered in this project?
A lot of the
The and recovering. The author, Mr. Andrea Bosira from Kenya. Mr. Adrian Bosir. Absent. The following paper, stability and accuracy of feature selection method using data sets of varying data complexity.
السلام عليكم.
وعليكم السلام.
نعم أنا موجودة أميمة الحسني، بس تعطون الصلاحية عشان نسوي أبلود للبرزنتيشن.
مرحبا بك أميمة.
Yes, Umayma, you have permission to do your presentation. Yes, now you can do your presentation.
Yes, Umayma, you have just 10 minutes to present the meaning of your presentation. Can you activate your mic, please? We don't hear anything.
So today, yes.
Okay, now good.
Good morning, everyone. This is Umayma Hosni. I'm a PhD student in artificial intelligence at the University of Aberdeen, Scotland. It is my pleasure to participate in this conference, and I'm very excited to exchange our knowledge and experience in artificial intelligence and machine learning. So today I'm going to talk about the stability and accuracy of feature selection method of varying data complexity. So as we all know that the machine learning algorithm and artificial intelligence in general are mainly dependent on data. So no matter how good these algorithms are, if we feeding this algorithm with the low data quality, the final result small sample size. In general, the power of the machine learning recognizing the pattern of the data is proportional to the sample size. So the smaller data set we have, the less accurate result. This will add challenging to the model to learn method has been Another advantage is to reduce the computational cost in terms of the running time and the computer capacity, since we will focus only on the few number of features. Also, it's improved the explainability of the results, since we can identify which feature has contributed in the final result. Eventually, it will improve the prediction accuracy of the model. In the literature, there is a huge contribution in machine learning and artificial intelligence community investigating the effect of the data challenges in the machine learning algorithm, whereas in the feature selection, the focus is relatively low. So that's why in this study, we aim to investigate if the feature selection method are data dependent or not, by investigating its accuracy and identifying the real feature and also its stability across different data characteristics. What we mean by stability? Stability is the ability of feature selection method to produce the same result across multiple runs in different data characteristics. To achieve the aim of this study, we designed our experiment strategy to be at 5 levels of difficulty according to the degree class overlap. As you can see from the plot, it starts with the level 1, which is the easy one, no overlap between the classes. Then it's moved to the harder level where the classes started to become close together until varying degree of class overlap. The reason for using different difficulties level because we are trying to simulate real-world problem, and real-world data set is normally associated with a class overlap problem. Another thing we are interested to investigate is the interactive effect of the class overlap with other data characteristics like small sample size against large sample size, noise against free of noise, small against large feature size, and balance against imbalance classes across different levels of difficulties. The purpose of using this investigation is to identify which are the challenges that has the highest impact on feature selection method in misdiagnosing the relevant feature. The experiment were conducted using 6 feature selection method mixed from filter, rabble, and omitted method. To make sure that we cover all challenges, we generate our scientific data to be in 2 scenarios, as we can see from the table. So the first table shows the small sample size scenario where the number of samples is 100 for the balanced data set and 16 for the unbalanced data set, where the second table shows the characteristic of the large sample size scenario where the number of samples is 1,000 for the balanced data set and 600 for the unbalanced data set. As we try to investigate the performance of the feature selection method across different feature size. So for the small feature size, we're investigating 50 features, 6 of them are relevant, and large sample size, the number of features 1,000 and 6 of them relevant in both scenarios across different levels of difficulties. Here we are showing only some of the experiment results. The rest of the experiment results are presented on the paper. So in this example, we're trying to investigate the selection performance of the 6 feature selection method in the imbalance classes dataset with the large feature size and in both scenarios, small sample size and large sample size across different degree of the class overlap. Why we're choosing this example? Because this example involves all of the data challenges that we are trying to investigate, like imbalance problem, large feature size, small sample size across different degree of the class overlap. So from the graph, it can see that the y-axis represents the 6 relevant feature, whereas the x-axis represents the difficulties level, started from the easy level, level 1 and level 2, where there is no overlap between the classes, until it's reached to the highest degree of the overlap at level 5. So from the experiment result, it can be clearly seen that most of the feature selection method can identify all relevant feature at level 1 and level 2 in both scenario, a small sample size scenario and large sample size scenario. And this indicates that the effect of the imbalance problem, small sample size, large feature size are relatively low when there is no overlap between the classes. But feature selection methods start to misdiagnose some of the relevant feature when it's reached to the level 3, where the classes start to become overlap at the decision boundary, which indicate that the interactive effect of the small sample size with the class overlap is high in the feature selection method compared to the large sample size where it shows better performance. And here we show the experiment result for the stability performance of the feature selection using the same data set mentioned in the previous slide. From the graph, it can be clearly seen that the stability performance had got similar result to the selection performance, where most of the feature selection methods have produced stable result at level 1 and level 2, while starting to produce unstable result when it reaches to the level 3, where the classes start to overlap at the precision boundary, especially in the small sample size scenario. Whereas showing good performance in the large sample size scenario, similar to the selection performance. So from here, we can prove that stability performance and selection performance are data dependent, since they produce different results across different data characteristics. So based on the experiment result, we can prove that feature selection methods are data dependent, since it produces unstable result and misdiagnose relevant feature across different data characteristics. Another important conclusion is that the effect of the noise high dimensionality imbalance classes are relatively low if the classes are linearly sparable. And we have proved this in the previous example. We show that most of the feature selection method can identify all relevant feature and produce stable results at level 1 and level 2, where there is no overlap between the classes in both scenarios, small sample size scenario and large sample size scenario. Another important conclusion is that in comparison to the other data challenges, the small sample size and the class overlap has the highest impact on feature selection performance. And also we have proved this in the previous example. We show that most of the feature selection methods start to misdiagnose relevant feature at level 3, where the classes start to overlap at the decision boundary. And this happened only in the case of the small sample size, whereas in the large sample size scenario, the feature selection method has shown better performance. So as I said before that, we are investigating the six feature selection method from the filter, wrapper, and amendment method. So our experiment results show that filter method, which is F-test, and embedded method, which is tree-based method, has shown best performance across different data characteristics in comparison with other feature selection method. This is the end of the presentation. Thank you so much for your attention, and feel free to ask any question.
Thank you very much, Umayma, for your presentation. Best future selection is a good topic to study phase to data and complexity of data and the size of data. Are there some questions, please? I have one. What do you think, Umayma, about using CNN, convolutional neural network, to reduce complexity of features?
I totally agree with you. The CNN now is the best, especially in the deep learning technique, because CNN involve filter at the beginning. It involved filter layer that help to extract the relevant feature. But the problem with the CNN, it's very good, it's perfect, but there is one problem with the CNN. We cannot use CNN in the medical report, in medical diagnosis. Why? Because it's black box. We cannot see what happened inside. That's why one of the main things that we are trying to do in my study is to develop method that transparent, explainable. So in the CNN, yes, that's right, we cannot use feature selection because it's powerful, it's very good, but it's black box. We cannot know why the decision has been made. And this is very important in medical diagnosis, yes.
Yes, thank you very much. Yes, it's a very convincing response. Especially we know our day there are many architecture about CNN and complicate architecture, but I think in some times that can result some medical problem, especially if we increase the performance of a training system.
Exactly, that's true. But when we need to know what is the cause of the disease, how can we know? We cannot know what is the cause, because it's important in the medical field to know what is the cause of the disease by identifying which feature that caused the decision. Yes.
Yes, thank you.
You're welcome.
Very much. We now the following presentation is about a roadmap for intelligent HVAC control in vehicle cabin. It will be presented by Mr. Muhammad El-Kadeshi Adnan Shaoud from the University of Michigan. Muhammad. Is absent. So the following one titled leveraging deep learning for computer vision, a review.
أستاذ دكتور منجي لو سمحت هل تسمح لي بملاحظة؟
تفضل.
دكتور محمد الحاج حسن بيتكلم معك.
أهلا.
كان في فكرة طرحنا فكرة في اجتماع البروفا بأنه في تسجيلات مسبقة في حالة أنه لم يستطع أي مشارك أنه يعمل برزنتيشن يشغل الفيديو. هل يوجد فيديوهات للأوراق التي لم يعني يقدمها أصحابها؟
لا، لم يوجد فيديو.
لحظة بس، عذرا للمقاطعة. يوجد نعم دكتور، ولكن إذا كان الفكرة في أن نعرض العرض في وقته عادي ماشي مشكلة، وإذا كان الفكرة في أن نبتدي بالموجودين ويقدموا أعمالهم والباقي نرجع للفيديوهات كما تريدون يعني
هو الأصل أنه لما الشخص يعني لا يتمكن من تقديم ورقته أن يشغل الفيديو كبديل في وقته. هكذا ناقشنا الفكرة على ما أذكر.
نعم، لكن
وهذا طبعا يعود للإخوة المنظمين في جامعة السلطان قابوس وللأخ رئيس الجلسة، لكن أحببت أن أذكر فقط.
لا، ملاحظة طيبة، لكن أنا نخلي بعض الوقت لتشغيل الفيديو إذا كان أمكن. إذا كان ما أمكنش نتعدى أوتوماتيكلي للفولوينج برزنتيشن.
على بركة الله.
على الوقت يجري.
نعم.
الظاهر توا واضح كون نقدموا الفيديو توا نرجعوا يعني الفيرست بيبر. لو تصحوا يعني البيبر identity 50 machine learning approach for the design of assessment outcomes. هذا الظاهر تو يلزمنا نمشيو للحل الثاني اللي هو pre-recorded presentations.
Doctor, we don't have in our storage device video number 15. So if you can other video or other.
Professor, can you hear me?
Yes.
Am I audible?
Adrian?
اي نعم، اذا كان حاضر واذا مش حاضر نتعداو للبيبر اللي بعده عاد نشوط.
Mr. Hilal, Chair. Mr. Hilal. Professor.
اي نعم.
Professor. Can you hear me? Professor, can you hear me?
تفضل. وي تفضل. Yes.
Adrian. I am Adrian. Can you hear me? From Kenya.
From Kenya. Okay.
I also sent my pre-recorded.
The title of your presentation using deep analysis.
Yes.
Adrian.
Yes.
Okay. You can present now.
Can they upload my video, sir?
Yes.
Okay.
All right, Mr. Adrian, already we have your video. Now we will go to play. Just make
Thank you.
share
Thank
the
you, Mr.
screen.
Hilal.
I think the hosting problem here. دكتور منجي،
نعم.
ممكن ترجع لي فقط الهوستنج بالنسبة للادمن، لأنه أنا طلع من الجلسة ودخل مباشرة ولغى علي دور الهوست، فإذا ممكن إنك ترجعها فقط من الإعدادات في البارتيسيبانتس وتخليني كهوست أو أحد من الكو هوست أو جميلة you heard me؟
أي ممكن جميلة اللي
جميلة.
أنا ما
Yes.
جميلة يعني لازم تخرج تكمل.
جميلة you heard us؟ تسمعيني جميلة؟ أميمة؟
Yes, you.
أميمة جميلة؟
نعم.
جميلة؟
نعم دكتور.
اوكي بليز بس غيري من الاعدادات وخليني انا الهوست. لان انا طلع عندي فجاه كذا تكنيشن ايشو ورقع بس ما اعطاني دور الهوست، فدور الهوست الان عندك يا جميله. تعرفي كيف تغيري؟
ميوت ولا مور؟
لا تروحي تحت شوفي البارتيسيبنتس تحت.
من وين لو سمحت؟
تحت في الشريط السفلي لما نعمل شير سكرين في موجود اول خيار اسمه بارتيسيبنت. وصلتي؟
من وين لازم؟
تحت شوفي مع تعملي شير سكرين وتشات وكيو اند اي وبعدين بارتيسيبنت.
ايوه
بعدين تروحي ظهرت معك شاشه على الزاويه.
ظهرني البين ليست فور
بالضبط. روحي على البين ليست.
ايوه
وغيريني انا مباشره اول واحده كوليج اوف ارتس، اختاري مور.
نعم.
بعدين تحصلي هوست. حصلتي؟
make a host yes.
ايوه بليز do
ان
that.
شاء الله.
Thank you. All right, now, okay. All right, now it's okay. So now let's share the presentation for Mr. Did you see now?
Present this paper.
Did you see the presentation now, please?
Yes.
All right,
Good.
let's move.
You have the talk, Adrian. You have just 10 minutes, please. We don't hear anything. Audio, please. Can you activate your mic?
The paper gives us a summary of the algorithms that were under consideration. This included deep learning algorithms as well as the swarm intelligence algorithms, whose performance and efficiency was actually analyzed using benchmark functions such as the ACRI function, the restrictive function, among others. And all this was measured using the mean squared error. The transport industry is essential in the growth of an economy because it facilitates resource sharing through the transfer of goods and services. Now, in modern society, the popular means of transport is motor vehicles, and this is evident through the elaborate road network infrastructure. As for the vehicles, they've actually been automated in order to reduce some of the human errors which they are prone to. As such, this automation of motor vehicles is actually aimed at improving the transportation process. Nonetheless, this particular industry is actually associated with some vices and crimes such as auto theft, and that informs the need to curb such risks. Some of the suggestions in mitigating such risks, as suggested by Alserin and Dietal, include the use of artificial intelligence, and it can actually be applied in the monitoring, tracking, detection, and recovery of stolen vehicles. It has actually been noted that the performance of algorithms based on deep learning supersedes those that are statistical based because of their meta-heuristic properties. And as such, this means that the optimality, completeness, precision, speed are guaranteed via the careful adjustments of their parameters and hyperparameters. This is aimed at assuring the confidence obtained in the results. Now, the previous studies that have been done in terms of the tracking, detection, and recovery of stolen motor vehicles usually rely on their physical features. As such, they employ the use of approaches such as the license plate recognition, the GPS tracking devices and sensors that may be installed or fitted on those particular vehicles and used for the geolocation and transmission of the vehicle's position. Now, these approaches are actually reliable up until such devices that have been fitted on such vehicles are either disabled, tampered with, or in some cases, removed. In this study, we are actually suggesting the use of deep analytics in the analysis of the driver's behavior, and from it, we can actually get the driver's driving signature, which can actually be monitored. And if there's a change in that driver's driving signature, it will help detect either a case of theft or track a vehicle that is on transit. And if it's a case of theft, then it may give us a chance to recover such vehicles. The vehicular trace data set that was used in this particular study was subjected to the following procedure. First of all, we started by loading the data set, then we processed the data, then defined from the various algorithms that we had. You will define an algorithm and configure its hyperparameters and parameters, after which you would define the activation function as well as the loss function, and then train that algorithm on that particular data set, from which you would actually obtain the driver's driving signature. And based on the various configurations that you've done, you optimize the network that are obtained, then we test the results that had been obtained. The DNN algorithms that were used in this study included the convolutional neural network, the recurrent neural network that has a memory cell, the deep Boltzmann machine, as well as the deep autoencoders. Then we also have the swarm intelligence algorithms, and these are the ones that were under consideration. That is the PSO, the ABC, the SEO, and the BAT algorithm. So those algorithms, that is the deep neural network algorithms and swarm intelligence algorithms, were implemented in the Python programming language. And of course, their parameters and hyperparameters were configured appropriately during several iterations to determine their peak performance. And this particular performance was evaluated in terms of the mean squared error, and that represents the average square difference between both the predicted values and the actual values. And all this was done using the procedure that was earlier indicated in the methodology section. This table presents the mean squared errors obtained during the analysis achieved by the deep neural networks. And all this was evaluated using the cost functions that have been listed in this first column. And on average, you can see from this table that it is the recurrent neural network that has a memory cell that performs on average better than the rest because it has lower MSEs or mean squared errors. The next table presents the mean squared errors that were obtained during the analysis using the swarm intelligence algorithms. And of course, they were also evaluated using the same benchmark functions. And for this particular table, you can see that on average, it is the artificial bee colony algorithm that performs relatively better than the other optimization algorithms. The data set was split into 3 divisions, that is 70% for training, 20% for validation, and the other 10% for testing. This will help us compare the obtained results against the original values. And as such, the results basically showed that the depth of the deep neural networks had minimal influence on the predictability accuracy. And as such, the hidden layers, if they were adjusted to past 50, they actually started slowing down the network. And in terms of the breadth of the network, that is the number of neurons per layer, the correlation with the number of features was actually evident. And this is because increasing the number of neurons past the 20 features that we had did not make much of a significant change in the mean squared error. So in essence, increasing the breadth and depth of the network had a relatively small impact on the performance. And there was some dependence on the features that were being observed. This meant that fewer features for a large data set actually increased the confidence levels as compared to the many features if they were to be studied for the same data. On average, the recurrent neural network that has a memory cell performed relatively better the other algorithms. And from the swarm intelligence algorithms, the ABC algorithm and the PSO algorithm also made good predictions. Nonetheless, when the parameters were slightly adjusted, they actually made significant changes in those particular optimization algorithms. And unlike the deep neural networks, which were actually dependent on the hyperparameter changes to lower the errors in their predictions. On overall, there was a high dependence on the hyperparameter and parameter tuning to the feature selection to achieve better prediction of the algorithms. And in conclusion, deep analysis of driver behavior can actually be used to specifically identify a driver based on their driving pattern. And as such, this information or this data can actually be used to improve the quality of driving and assure the safety based on the rear. Now, the other thing to consider is that the driver's driving signature is dependent upon the experience and skill. And this is actually shown in their reactions over time, which is quite dynamic because they may be influenced by other extenuating factors such as the weather, road condition, and even the kind of occupants that are present in the vehicle. Lastly, in this reference section, we have a listing of some of the references that were used in our presentation. Thank you very much.
Thank you, Adria, for your presentation. Are there any questions, please? Any question? No question. So I have one. Adria, what the function that you use it in the training step? What's the activation function?
The activation function.
Use it.
Oh yes, for the activation function is basically to standardize that particular data, basically to normalize. And the one that was that was fairly well, that gave us dependable results, was the sigmoid function. Because if you were to use something like the hyperbolic tangent, then it skewed the result, and it actually made those particular neurons to react differently, which gave us a very...
What about
Yes.
What about ReLU function? ReLU function don't give good results. ReLU function.
Yeah, that one works best, especially when you're working with
Yes.
the convolutional neural network.
Okay.
Because
do you
yes?
do you use the dropout and the max pooling and so
Yeah, the soft max
on in your training system? Soft max. Okay.
Yeah, soft max.
Okay. Thank you very much.
Thank you very much, sir. Hello, can you hear me? Can you hear me?
Thank you, Adria. We go to the following presentation. Please, I asked if someone is present here now. The first paper, Fatim El Zahra, Adnan Shaoud, Muhammad, Akram. If not, we video, please. Yes.
Which one?
The paper identity 15. Fatim El Zahra, machine learning approach for the design of an assessment outcomes recommendation system.
I think we don't receive this video from the author, I think, because we don't have this video.
Okay, Adnan Shawood, the following one, 52, identity
52.
52, an embedded deep learning computer vision method for driver distraction detection.
52.
Yes.
Yes, here. All right.
52 and 54. So we can see the after one 54, the same author, Adnan Shawood. Okay, 52.
Hello, my name is Benjamin Roybird, and today I'm going to be presenting on an embedded deep learning computer vision method for driver distraction detection. And the advisors for this paper were Adnan Shawood and Luis Alejandro Sanchez Perez. The purpose of this paper was to create a method of detecting driver distraction using computer vision methods within an embedded real-time environment. And this method should be comparable in performance, such as accuracy and speed, to similar systems not in an embedded real-time environment. And this method will use the following technologies to achieve this: the American University Cairo Distracted Driver Dataset, Squeezenet Deep Learning Network, and the Jetson Nano Embedded Computer. Before we can detect driver distraction, we first define it. And according to the National Highway Traffic Safety Administration, or NHTSA, driver distraction is any activity that diverts driver's attention from the main task of driving. That can be things like eating, drinking, looking away, anything the driver's doing. And we can actually measure those things like in an image or through sensor data through things like gaze direction, physiological features, cognitive distraction, etc. This paper we propose using driver pose to detect driver distraction because it's a rather broad definition and encompasses many different driver distraction modes. And we can actually detect driver distraction through pose using computer vision, which is an image of the driver, as you can see on the right here. And we can use things like deep learning or artificial intelligence to detect driver distraction in these images here. This paper will be using deep learning to detect driver pose. And now that we have our deep learning methodology and kind of our way of detecting passive driving, how do we actually deploy it into a real-time environment? So we do that using embeddable hardware such as an FPGA, microprocessor, or a controller. And for this paper, we're actually going to be using the Jetson Nano. It's going to be running our driver distraction system. We're going to be taking the AUC distracted driver dataset, which is a dataset of distracted driver images, and we're going to be modifying those images to be ran with our chosen deep learning network, Squeezenet, which is also going to be running on the Jetson Nano hardware. So in short, the Jetson Nano is going to be running Squeezenet as a deep learning network, and it's going to be predicting on AUC distracted driver dataset images, whether the image is of a distracted driver or a safe driver. A bit of background about Squeezenet. It was a convolutional neural network originally developed for FPGAs, or field programmable gate arrays. And what makes it so powerful is that it is accurate. Squeezenet is as accurate as networks that are 50 times larger than it. So it's much smaller while retaining similar accuracy as like a network such as AlexNet, which makes it perfect for embedded deployment. Here's a quick background on the AUC distracted driver dataset. These are images from the 10,000 or so images within the dataset itself. As you can see here, there are 10 different classes of driving, one of them being safe driving and the other 9 being different modes of distraction, drinking water, talking on the phone, texting, etc. And this data set has been used in many other papers, particularly in regards to driver distraction detection using deep learning computer vision. So it's not a untested data set. Before we actually start testing things, it's important we first design our software. So this paper is going to require a main program. It's actually going to load the AUC data set into a model, which will be Squeezenet. So desktop PC is going to be taking care of loading in our data set, building our deep learning network Squeezenet, and training it. Then we use a thing called Tensorflow Lite, which is a deep learning framework, which is going to take our deep learning model, compress it to be deployed on embedded hardware, being our Jetson Nano. And the Jetson Nano is actually what's going to be running the Tensorflow Lite model and actually performing predictions. Now, to use Squeezenet, we actually have to modify it a little bit, and that comes in the form of reducing the amount of parameters in it. So the original Squeezenet has around like 1.2 million parameters. It's classifying 1,000 different classes of images. But our version of Squeezenet is only going to be classifying 2 classes of images. So that brings the size down to around 92,000 parameters. Here is a top-down kind of diagram of what Squeezenet looks like in our case. We have the input layer fed into these things called wire modules, which are layers of Squeezenet that can hold a lot of information. And our output here is 2 classifications, distracted driving or safe driving. Now, a little bit about the AUC distracted driving dataset. It contains 30 drivers and 10 classes of equivalent drivers. And to make this problem a little simpler, we're shifting our dataset to put the 9 different modes of distracted driving in one class and leaving the 1 class of safe driving as its own class. This creates a bit of a lopsided dataset, which we account for through image augmentation, as you can see on the right here, by adding more data. Squeezenet, one of the reasons it's so powerful is that it can be compressed and quantized. The original Squeezenet was around 4.8 megabytes compressed, but after compression, it was around 2.7 megabytes. In our case, our network is around 4.26 megabytes, and compressed is around 0.904 megabytes, which is still much smaller than, say, a network like AlexNet, which is 240 megabytes. And of course, we're going to be taking our compressed version of Squeezenet and running it on the Jetson Nano. The Jetson Nano is going to be running a Linux-based operating system, and it's going to run the TensorFlow Lite model in Python. So on the Jetson Nano, it's actually going to be making the predictions using Python in this kind of Linux environment. Performance of our model is as follows. As you can see here, we got a 94% accuracy for distracted driving, and an 86% accuracy safe driving. And it got the performance running on this piece of GPU here, this GPU, at a performance around 32 frames per second. And of course, what's really important is the performance on the Jetson Nano. As you can see here, there's only like a 1% drop in accuracy of distracted driving and a 1% increase in accuracy of safe driving. So pretty similar to desktop performance there. You'd get a drop in FPS from 32 FPS to 11 FPS on the Jetson Nano, but this performance is still comparable to other implementations. As you can see here, here is the implementation of real-time detection of distracted driving based on deep learning. So it's a similar approach, except it takes a different kind of data set, one made by the authors, and it runs it on a Jetson TX1, which is a more expensive piece of hardware, using larger networks such as AlexNet. And it got a performance of around 11 FPS with 93% accuracy, which is pretty similar to this paper, except this paper uses a smaller network and cheaper hardware. Here's a diagram of the implementation. It shows that the TX1 performs the driver distraction detection, and they have their own kind of test bed to actually capture this data. In conclusion, we were able to get around 11 FPS performance on the Jetson Nano with around a 94% accuracy of distracted driving. So this shows that we were able to successfully deploy a driver distraction detection method into a real-time environment. We did get a pretty high drop in FPS performance, but that's to be expected when moving from more powerful to weaker hardware. But what's most important is that we were able to actually deploy it in a real-time environment with performance comparable to existing implementations, except on smaller and cheaper hardware. Thank you.
Good. Even the author is absent. Can we go to the following presentation for 54, please? State of the art of smart doorbell systems. The same author, Dr. Adnan Shaoud.
We don't have in the list, Doctor. Let's go to another.
The following one is the number, identity number 99.
99.
Muhammad Al-Kaddashi, the author. And the title of this paper, a roadmap for intelligent HVAC control in vehicle cabin. 99.
Yes, here. All right.
Okay.
So let's do share and play.
A Roadmap for Intelligent HVAC Control in Vehicle Cabin by Mohammed Al-Kadashi and Dr. Adnan Shahoud, the ECE Department, the University of Michigan, Dearborn, USA. This project is conducted at the University of Michigan College of Engineering, Electrical Engineering Department as a fulfillment for master thesis requirement for Mohammed Al-Kadashi under the supervision of Professor Adnan Shahoud. About the authors. Dr. Adnan Shahoud is a professor and Fulbright scholar at the University of Michigan, Dearborn. He earned his bachelor's, master's, and PhD in computer engineering from Syracuse University. Dr. Adnan Shahoud's research areas are automotive engineering, computer and networks, cybersecurity, data science, human factors and ergonomics, integrated design and manufacturing, machine learning, optimization, and intelligent systems, as well as software engineering and wearable sensors. Dr. Adnan Shahoud has published a number of books, participated in many papers, and also have a number of patent inventions. To see the full list of Dr. Adnan's accomplishments in his professional career, please see the link below. Mohammed Al-Kadashi, an electrical engineer, earned a bachelor's in electrical engineering from Wayne State University and currently working on master's in electrical engineering at the University of Michigan, Dearborn, with an expected completion of May 2022. Areas of interest and previous research areas are transportation electrification, automotive engineering, machine learning, intelligent systems, autonomous and process optimization. Previous publications, 2 publications in the areas of ADAS safety. This paper is intended to provide an overview of HVAC reviews. Survey aims to determine any room for improvement in the area of HVAC control. The survey reviews many areas where HVAC control is currently being used, has been used in the past, or is proposed to be used in the future. The scope of implementation that will follow this review will be in the area of transportation, namely vehicle transportation. Findings tend to increase comfortability and energy efficiency. Implementation opportunities after the review has suggested that a new control method, an integrated method of LDA, linear discriminant analysis, and KD, Kalman decomposition, for prediction and control. There is no doubt that intelligent systems are on the rise to aid with user interface and task execution. In parallel, there is an exponential growth in electrification in the automotive industry in an effort to promote clean energy and reduce CO2 emissions. In this paper, it addresses the comfortability, namely the vehicle cabin temperature. A proposal is put forward to develop an intelligent HVAC control to aid with the following. Driver-passenger, also known as occupant, identification strategy. This section examines the variety of identification verification strategies. Each have their advantage and disadvantage, some of which require special equipment and others do not. Also, security level has been examined in this section as well to understand the levels of security. These identification strategies show to be able to be implemented in a vehicle setting. There are a number of identification strategies that have been studied in the past. A variety of those examples are captured in this paper, some of which have their advantages and disadvantages, and others that require special equipment. Also, security level is a key and critical variable when studying identification strategies. Driver-passenger temperature input normally requires the user to define their preference for temperature within the cabin. It is normally a manual process. In addition, closed loop and open loop HVAC systems are normally closed loop for better control. Older systems, though, tend to have open loop, which does not control as great. Cabin temperature control. You can see to the right in the architecture, there is input data, which has a user input and reference the outdoor temperature. In the controller unit, it takes in the input, and in addition, it references other parameters, such as humidity and cabin temperature. With that together, then outputs the data, which is a temperature preference set point for the cabin. This section examines the variety of control algorithms that have been researched, studied, and published in the past. There are a variety of models, algorithms that tend to increase efficiency and reduce energy consumption, and also provide comfortability and aid with task execution. This section also studies the past, present, and future of the HVAC control. Also, the space, residential, commercial, and transportation is taken into consideration as well. In this section, linearity and system structure is also examined, and also implementation, whether it's simulation, prototype trial, or a combination of both, is being documented in this section. This paper also includes a section for previous reviews of control techniques. Reviews in the past include variety of control algorithms. Most of algorithms show promising efficiency results and other benefits. Some reviews include new techniques in addition to reviewing other additionals for uniqueness of the review. It also reviewed past and present work within the reviews. It also reviewed implementation of different settings, such as commercial, industrial, home, or transportation. It also reviews the ease of implementation. Previous reviews also highlight efficiency in classification for comparison, some of which also highlight potential future improvement and suggestion, potential future path for technology. It also recognizes that HVAC is a significant energy consumption variable and could be challenging for electrification in the transportation space. And therefore, it is an advantage for implementation in autonomous vehicle if HVAC control is being reduced to efficiency state. As a result, common decomposition and linear discriminant analysis integration control prediction is being proposed. Linear discriminant analysis is used for occupation prediction. It monitors external parameters and looks at previous input used for training. It conducts the training and testing within the model and will potentially provide a better accuracy score for prediction. Kalman decomposition, KD, which is the second half of this algorithm. It comes in after LDA, in which has intention to control the HVAC in real time. It takes in four main variables: cabin temperature, which is considered controllable and observable; humidity, which is controllable and non-observable; outside temperature, which is non-controllable but observable; occupant attire, which is non-controllable and non-observable. With that, it would output a cabin control set point per the occupant's preference. In conclusion, large number of studies have been approached for HVAC control. Studies tend to address efficiency and comfortability. HVAC control advanced over the years in both sectors. Intelligent, smart systems aid with HVAC energy and control efficiency. HVAC has become a necessity in some environments, if not most environments. Autonomous and electrification support the optimization of HVAC, as it is a main contributor to energy consumption. Therefore, study integration of LDA and KD for HVAC systems have been proposed. It is believed that a combination of prediction and control to optimize the user interface in the HVAC control space could provide a better and more efficient system. Thank you.
Okay, if it is possible to go the following paper, the paper identity 121. Leveraging deep learning for computer vision, a review. The author name Karam Alam from India. Is the video ready?
Yes, 1-to-1 is ready.
Okay, please.
1-to-1 leverage deep learning.
Yes.
The last one.
The last one, yes.
All right.
Hello everyone, myself Ikram Alam. I am from Department of Computer Science, Gorma Vidyalaya, India. My topic is leveraging deep learning for computer vision's review. These are the outlines: introductions, computer vision, or component task of computer visions, deep learning, relationship of deep learning with artificial intelligence and machine learning, and different types of deep learning models, especially CNN models. Applications of deep learning in computer vision, especially in image classifications and different types of models which have been used for classifying the image, and the applications in different fields of computer vision. Conclusion and future scope, and finally the references. So introductions. Why deep learning? Deep learning provides a very high performance. It gives very good accuracy. It can also extract features automatically. There is no need of any
handcrafted features. The problem with deep learning models are these are very data hungry, and also it requires very high computing device, especially for the training. So the problem of high computing device can be solved using different types of cloud computing. For example, Google Cloud is available. Also, the computing power of the devices, laptops, desktops, mobile phones are increasing day by day. So this should not be a problem. Also, the problem of huge data requirement can be solved because we are surrounded by different types of sensors, especially vision sensors are available everywhere, in room, airport, street, railway stations, hospitals, nursing shops. There are lots of cameras and vision sensors which are capturing the data day by day, and huge amount of data is generated. So those data can be utilized in deep learning models. Obviously, there are some fields where data requirement of data is a problem, especially in medical image analysis due to the privacy and some other reasons. The data is not available in huge amount. In those fields, transfer learning can be utilized. In transfer learning, first we train the model using any available benchmark data sets, and we then increase the weight of some layers, majority of the layers except some higher layers, and we then retrain using the problem data sets. Now, the basic fields of computer visions where deep learning can be utilized are smart surveillance and monitoring system, unmanned aerial vehicles, health robotics, sports, autonomous or self-driving vehicles. What is computer vision? The goal of the computer vision is to provide the capability of human vision to the computers. So what is the difference how a human see an image or anything and how a computer see? This is what a human see an image look like this, but when this image will be stored in a computer, this is nothing but some combination of numbers in row and column wise. For a grayscale image, the value of this number will range from 0 to 255, 0 for black and 255 for white, and intermediate values for different sets of blacks or white. For a binary image, the value will be 0 or 1, 0 for black, 1 for white. For RGB image, there will be 3 matrices for every image, 1 for red, another one for green, another one for blue. And the combination of this value will generate different types of colors. There are 4 types of board tasks in computer vision: image classification, object localizations, object detection, and segmentation. Segmentation can be of 2 types: instant segmentation and semantic segmentation. So in the first figure, the example is of image classification. In image classification, the task is to label an image or to classify image from the available labels. So this will be detected as bottle. The object localization is the task of classification as well as localizations, that means to provide a bounding box, provide locations around the object. In object detections, it's similar to object localization, but here there may be more than one objects in a single frame. This is the example of instant segmentation. In segmentation, the labeling is done pixel-wise. Each pixel is labeled based on some similarity, some common features on the basis of colors or textures. So this is a one instance. There is a segmentation. There are 2 instances of bottle, so they are segmented differently. So artificial intelligence. Before going to the deep learning, what is artificial intelligence? The goal of the artificial intelligence is to provide the computer thinking power like humans. Machine learning is a subtype or subset of artificial intelligence where machine learn itself using training. And deep learning is a sub part of machine learning. Okay. Now, deep learning.
What is the difference between traditional programming approach and machine learning programming approach? In traditional programming approach, we have some hard code program in input data and we get some results. In machine learning approach, there are lots of data and their level or output, and while learning, it will generate a program, and using that program or that learning, we will get the output from some test data. This is an example of CNN. CNN has different types of layers. This color is for convolutional layer and some activation function. ReLU is the most common used activation function. Then pooling layer, then some dense layer, and finally fully connected. This is the operation of convolutional operations. This is basically summation of the element-wise multiplications. So this is the filter or weight, and just multiply the element-wise, you will get 2. Again, shift by 1. Again, you will get 2. Shift by 1. You will get 2. Shift by 1. You will get 4. In the same way, we will get the result after convolution. This is also example of convolution. This is the example of max pooling, where we have taken 2 by 2 window. So maximum value is 32, here maximum value is 50. Like that. These are the image classifications model which have been used in ImageNet datasets. And we can see the top 5 error has been reduced from 16.4 to 2.25, far less than the human. Human has top 5 error rate 5. Now the applications of deep learning in other fields. The other fields are 3D image reconstructions. We have provided 2 recent work: depth estimations, face recognition, human activity recognitions, image captioning, image classifications, image reconstruction, image retrieval, medical image analysis, object tracking, pose estimations, scene text detection and recognition, scene understanding, shadow detection, video summarization, visual question answering, and there are many more fields where deep learning can be utilized. Now the conclusion is, obviously there have been lots of work using deep learning in computer vision which are providing a very good results. Some future work can be to design a model which can work in low computing handheld IoT devices. Also in deep learning, we cannot auto-tune hyperparameters. We have the different hyperparameter values. It is dependent on problem to problem, and we have to check it. So in this field also, there may be the requirement of work. Obviously, another problem is that deep learning models in general does not work in arbitrary size images. That means very few work has been done in this field also. So here also there are lots of scopes, and these are the references. Thank you very much for listening. Hello everyone.
Thank you very much, Akram. Mike, are there any questions at first? Any question, please? No question? I have some questions, Akram. Why you use Google Colab platform?
Sir, Google Colab can be used when the requirement of high computing is needed. In deep learning models are basically they require lots of amounts of computing, especially in training. So if we don't have high computing devices in our lab setup, we can use Google Colab to run our program in the cloud for the training specifically.
Do you think that it's very beneficial for for PhD student to use this platform and benefit from Keras and TensorFlow libraries?
Now, all libraries are available in Google Cloud also. If there is a problem in computing, then only Google Cloud can be used, or if there is no issue, then we can use the lab setup.
But about
because in Google Cloud we can execute the program and we can also log out, and the program will run in the Google Cloud server, and we can check after 1 or 2 hours the outcome or the second day. So there is no need to start our
my question: if you have
all time.
If you have already execute your program by Google Colab, after that you want to implement your project on processor for as embedded system, can you manage this work?
I have not tried, but I think after training we can download the file and we can use in the embedded system.
After
training.
After finishing training and so on, and using yes, can you implement the system, the predicted model? Can you implement your model on a system on chip, for example, to FPGA as an embedded system?
Yes, if after training, also in testing time, also some computing power is required. If the embedded system is very lightweighted in respect of computing power, then our design goal will be different for low computing devices.
And what do you think about the outcomes, your perspectives about after review? It's a good review. Your work is very interesting. But after this review, what do you think about what your project in the future?
I have started working in human activity recognition, especially fault detections. So at present, I'm working in this field, how deep learning can be used in human fault detection for the senior citizens who are living alone.
Okay, thank you very much again for your presentation. And now I don't
Thank you.
know if there are other Enam.
It's pretty, if the authors is available with us.
Are there some other available now?
Number 52, the video is ready.
Okay, we can see that.
So we'll start with 52, huh?
52, okay. Thank you very much. Thank you. 52 is titled An Embedded Deep Learning Computer Vision Method for Driver Distraction Detection.
Hello, my name is Benjamin Ripper. Today I'm going to be presenting on an embedded deep learning computer vision method for driver distraction detection. And the advisors for this paper were Professors Adnan Chahoud and Luis Alejandro Sanchez Perez. The purpose of this paper was to create a method of detecting driver distraction using computer vision methods within an embedded real-time environment. And this method should be comparable in performance, such as accuracy and speed, to similar systems not in an embedded real-time environment. And this method will use the following technologies to achieve this: the American University Cairo Distraction Driver Dataset, Squeezenet Deep Learning Network, and the Jetson Nano Embedded Computer. Before we can detect driver distraction, then we'll first define it. And according to the National Highway and Traffic Safety Administration, or the NHTSA, driver distraction is any activity that diverts the driver's attention from the main task of driving. So that can be things like eating, drinking, looking away, anything the driver's doing. And we can actually measure those things like in an image or through sensor data through things like gaze direction, physiological features, cognitive distraction, etc. This paper we propose using driver pose to detect driver distraction, because it's a rather broad definition and encompasses many different driver distraction modes. And we can actually detect driver distraction through pose using computer vision, because it's an image of a driver, as you can see on the right here. And we can use things like deep learning or artificial intelligence to detect driver distraction in these images here. This paper will be using deep learning to detect driver pose. And now that we have our deep learning methodology and kind of our way of detecting defensive driving, how do we actually deploy it into a real-time environment? Well, we do that using embeddable hardware such as an FPGA, microprocessor, or a microcontroller. And for this paper, we're actually going to be using the Jetson Nano. It's going to be running our driver distraction system. We're going to be taking the AUC distracted driver dataset, which is a dataset of distracted driver images, and we're going to be modifying those images to be ran with our chosen deep learning network, Squeezenet, which is also going to be running on the Jetson Nano hardware. So in short, the Jetson Nano is going to be running Squeezenet as a deep learning network, and it's going to be predicting on AUC distracted driver dataset images, whether the images of a distracted driver or a safe driver. A bit of background about Squeezenet. It was a convolutional neural network originally developed for FPGAs, or field programmable gate arrays. And what makes it so powerful is that it is accurate. Is that Squeezenet is as accurate as networks that are 50 times larger than it. So it's much smaller while retaining similar accuracy as like a network such as AlexNet, which makes it perfect for embedded deployment. Here's a quick background on the AUC distracted driver dataset. These are images from the 10,000 or so images within the dataset itself. As you can see here, there are 10 different classes of driving, one of them being safe driving and the other 9 being of distraction, such as drinking water, talking on the phone, texting, etc. And this data set has been used in many other papers, particularly in regards to driver distraction detection using deep learning and computer vision. So it's not an untested data set. Before we actually start testing things, it's important we first design our software. So this paper is going to require a main program, which is actually going to load the AUC data set into a model, which will be Squeezenet. So desktop PC is going to be taking care of loading in our data set, building our deep learning network Squeezenet, and then training it. Then we use a thing called Tensorflow Lite, which is a deep learning framework, which is going to take our deep learning model, compress it to be deployed on embedded hardware, being our Jetson Nano. And the Jetson Nano is actually what's going to be running the Tensorflow Lite model and actually performing predictions. Now, to use Squeezenet, we actually have to modify it a little bit, and that comes in the form of reducing the amount of parameters in it. So the original Squeezenet has around like 1.2 million parameters. It's classifying 1,000 different classes of images. But our original Squeezenet is only going to be classifying 2 classes of images. So that brings the size down to around 92,000 parameters, which is significant. Here is a top-down kind of diagram of what Squeezenet looks like in our case. We have the input layer fed into these things called wire modules, which are layers of Squeezenet that can hold a lot of information. And our output here is 2 classifications, either distracted driving or safe driving. Now, a little bit about the AUC distracted driving dataset. It contains 30 drivers and 10 classes of each of those drivers. And to make this problem a little simpler, we're shifting our dataset to put the 9 different modes of distracted driving into 1 class and leaving the 1 class of safe driving as its own class. This creates a bit of a lopsided dataset, which we account for through image augmentation, as you can see on the right here, by adding more data. Squeezenet, one of the reasons it's so powerful is that it can be compressed and quantized. The original Squeezenet was around 4.8 megabytes compressed, but after compression, it was around 7 megabytes. In our case, our network is around 4.26 megabytes, and compressed, it's around 0.904 megabytes, which is still much smaller than, say, a network like AlexNet, which is 240 megabytes. And of course, we're going to be taking our compressed version of Squeezenet and running it on the Jetson Nano. The Jetson Nano is going to be running a Linux-based operating system, and it's going to run the TensorFlow Lite model in Python. So on the Jetson Nano, it's actually going to be making the predictions using Python in this kind of Linux environment. Performance of our model is as follows. As you can see here, we got a 94% accuracy for distracted driving and around an 86% accuracy for safe driving. And it got the performance running on this piece of GPU here, this GPU, at a performance around 32 frames per second. And of course, what's really important is the performance on the Jetson Nano. As you can see here, there's only like a 1% drop in accuracy of distracted driving and a 1% increase in accuracy of safe driving. So pretty similar to desktop performance there. We did get a drop in FPS from 32 FPS to 11 FPS on the Jetson Nano, but this performance is still comparable to other implementations. As you can see here, here is the implementation of real-time detection of distracted driving based on deep learning. So it's a similar approach, except it takes a different kind of data set, one made by the authors, and it runs it on a Jetson TX1, which is a more expensive piece of hardware, using larger networks such as AlexNet. And it got a performance of around 11 FPS with 93% accuracy, which is pretty similar to this paper, except this paper uses a smaller network and cheaper hardware. Here's a diagram of the implementation. It shows that the TX1 performs the driver distraction detection, and they have their own kind of test bed to actually capture this data. In conclusion, we were able to get around 11 FPS performance on the Jetson Nano with around a 94% accuracy of distracted driving. So this shows that we were able to successfully deploy a driver distraction detection method into a real-time environment. We did get a pretty high drop in FPS performance, but that's to be expected when moving from more powerful to weaker hardware. But what's most important is that we were able to actually deploy it in a real-time environment with performance comparable to existing implementations, except on smaller and cheaper hardware. Thank you.
I think that this paper is presented twice. We need 54 and not 52. The title is State of the Art Smart Doorbell Systems 54. Please.
It's all not available. We have 72.
72. Okay. We
Yes.
go to 72. The title using deep analysis of driver behavior for vehicle theft detection and recovery. Okay, 72. And the last one.
To present this paper that is titled Using Deep Analysis of Driver Behavior for Vehicle Theft Detection and Recovery. It is authored by both I and Damien Maingi. But
it has already sorry, it has already presented.
Already presented?
It's already presented and evaluated 72.
Yes.
That's all.
That means
خلاص كملنا.
yes.
Is just 54 is not already 54.
Yes, we don't have.
and 15 50 50 و 54 50 identity number 15 the title machine learning approach for the design of an assessment outcomes recommendation system.
Yes, oh, we have.
I think that the author is present, no? Fatim al-Zahra, you are here, Fatim al-Zahra.
Not here, Fatima Zahra.
Not here. Okay. The last one. Okay.
Hello. Assalamu alaikum. This is Dr. Raed. I'm presenting this paper on behalf of my colleagues, Fatima Al-Zahra, Lamiz Dalba, Shayma Munir, and me. This is about machine learning approach for the design of
Okay, welcome.
outcomes.
Yes. Yes, any doubts?
Recommendation system.
Okay.
This work is essentially guidance framework for teachers and instructors to use in their education at schools and universities. We try to analyze the outcome of a course, and we try to figure out what are the recommendations that should be done in order to improve the performance. Of course, we compare the results to the recommendations that are provided by emirates. We call it a QM emirates for the level of the course that they are teaching, which is mostly here we are talking about bachelor degree courses. So there are some recommendations, actions that are shown to the right that we recommend that the students should be doing based on the analysis of the performance of the study. Of course, the analysis depends on the achievement of the course learning outcomes that are already specified and stated in the syllabus of every course. So the model that we are using is a neural network model, and it takes several inputs and gives the recommendations. You have seen the models of the neural network to the right. The targets are the recommendation, while inputs are the values of the evaluations of the course learning outcomes. And we try to build a compact, parallel recommendation system that can learn how to map the proper recommendations based on the inputs that they receive. Well, inputs, of course, they are the evaluations of the course learning outcomes. We have used an algorithm called backpropagation algorithm, which is a straightforward learning algorithm. And the idea was to find the best architecture that fits this kind of machine learning paradigms. Course learning is based on finding the best weights, the weights of the neural network in the two layers that minimizes the error. The error is the output of the neural network compared to the targets, and the targets are the recommendations. Those recommendations are giving labels. And there are several weights that have been tested from 1 until 6. And these are the values of the weights that have been found to minimize mean square error, which is like a convex function that needs to be minimized. Once it's minimized, then we can know that the neural network have learned how to do the matching between any possible input of the learning outcomes and the correct or close to correct labels that are usually mapped to the recommendation system outcomes. The idea was to find the best number of hidden neurons in the hidden layer. The number of hidden neurons is not known, and the inputs are fixed, of course. The number of inputs is fixed, the number of outputs are fixed, the targets are fixed. But what we were looking for is to find the optimal number of hidden neurons in the hidden layer, and it turned out that 11 is the best. Of course, now we don't have a real justification why 11 is the best, because it is a heuristic. We tried based on the data that we have and the complexity of the mapping that we have. More than 11, we will have what we call overfitting, and under 11, we will have underfitting. So to avoid the overfitting with underfitting, the best thing was to use 11 neurons. Although we might have less value of errors if the hidden neurons were more than 11, 12, or 13, but the performance was not good. When we did the verification and validation and testing, the best thing we achieved was when the number of neurons was equal to 11. Of course, as a machine learning system, it has to be validated or tested based on what we call a confusion matrix. And we had to calculate the accuracy, will recall, will F1 score, will precision, in order to figure out the performance. And as I told you, we got best results for those three performance indices when we had hidden units is equal to 11. This table shows the performance matrix or confusion matrix at the last row, the accuracy with precision, with recall, with F1 score. Each one of them has a meaning, and the higher those values, it means the better is the performance. And based on that, we did the evaluation for the testing. When we did the testing, we had to use those performance measures, confusion matrix measures. And this is different than the mean square error that is used in learning. But these are the parameters that reflect the performance during testing and mean when the learning is finished. What we are trying to calculate is something that we call true positive. True positive means the answer is true, result is true. When you say true negative, means the answer is negative and it is true. When you say false positive, the answer is positive, but this is false, it's not positive. When you say false negative, the answer is negative, but this is false, it's not negative. So these are the four values that usually get when we do the classification. The learning system should be able to do the right recommendation. And any result that the learning systems come up with has to be one of those four values: TP, TN, FP, FN. And based on those, we calculated confusion matrix values. The equations for calculating confusion matrix values, which are in accuracy with precision or recall, F1, are shown in the paper. The conclusion is that we managed to build a compact, straightforward, simple machine learning system that does work as a recommendation system that can be used by educators without them having to be experts in computer science or machine learning. What they have to do is to calculate a course learning outcomes for every course, and then they feed it to this compact neural network that is already being trained, and then they get the recommendations that they should be applying on the course in the future, and the next time they teach it. Recommendations could be, for example, having more examples, or having more practical work, or changing the textbook, or, for example, having a lab, or anything that can enhance the educational experience and the educational outcome. Of course, this could be retrained and retrained again, and any new outcomes or any new standards could be used again in the training. This is recommended to be applied for every course. Every course you can have a neural network or a recommendation system that you can use. But of course, it cannot stay fixed forever. It has to be updated with knowledge and updated with the training every time the course is taught. This will enhance the outcomes of the system when it is used in the future.
That's it.
That's it. Okay, thank for this presentation. We thank the author for this presentation. Are there any paper to present? Now, I think that we have just 54. Is that 42? Okay. Just 54.
We don't have the video for 54.
Okay, now we can. That's it. We
Closing
the session is closed.
Yes.
Okay, we will give all evaluation parameters to steering committee and the chair. To after that, we can know the best paper of this session. I thank you very much for your attention and your presence. Thank you for all. And for the organizer from Oman, really it's hard work, and especially it consists of online. It isn't a very practical way, but we inshallah we success. وبارك الله فيكم وإلى اللقاء.
Thank you very much for all, and see you in the other season. Now we will shift to season 5. I'm so sorry.
Okay, thank you very much.
مع السلامة. شكرا جزيلا لكم جميعا.
مع السلامة.